Hi, like I said in class, I would go over the concrete experiment in a video. That's what this is. First thing, in my section, this is not a required assignment. If you do it, I will give you some extra credit, especially if you need it. Having said that, this should not take very long, and it would be very useful for you to mess around with concrete a little bit, and it'd be fun for us to have some samples to cut and examine. Also, I've created this is actually a simplified version of the spreadsheet that I showed you in class quickly. It's good to start messing around with Excel, so this will be another opportunity for you to learn that. All right, so before I go into the spreadsheet, though, let's look at, we'll just remind ourselves what we're doing. We have now two lectures on Canvas on concrete, so remember that those are there. They have very good graphics in them, and there's some information in both of those about mix design that you could look at. You can also just look around the web to get some feel for it. Like you'll find charts like this. The basic point is we have a structural matrix, which is going to be some big hard things, coarse aggregates, and some smaller hard things, fine aggregates. The typical example of those are smaller rocks called gravel of various sizes, and then those are mixed with sand. The sand fills in the spaces between the rocks, and you get this sort of structural matrix, and then you fill in the gaps between that with cement, which is the Portland cement powder we gave you, plus water, and that creates a structural uh, composite. Additionally, as we've talked about, concrete very often has a tensile reinforcement added. Remember that it's strong in compression but weak in tension. In large scale concrete, often that uh, tensile reinforcement is steel in the form of rebar, long rods of steel, and that's because steel is strong in tension. You can also, though, if you a lot of slabs will just have either little pieces of fiberglass in them or actually a gridded plastic mat that's a tensile reinforcement. So you could find ways of tensily reinforcing your mixes without using steel. So anything that's a little bit longer than aggregate and is strong in tension, so something you could pull on and not break. So like a drinking straw would be that. Uh, Thin strips of plastic that you cut up could be tensile reinforcement. Um, and you'll see that if you use something like that and we were to cut into your concrete, it'll probably be that's it's clear that that's sort of holding it together in a way that the concrete itself isn't. Maybe not, but and that's optional. But the point being that we have a variety of materials that come together to make our mixes, and you can. The point of this assignment is to uh, play around with them. So I made this spreadsheet to help you keep track of um, your mix design. The process for making the mix design is defined here or laid out here. First, you're going to collect your materials. You're going to have the cement we gave you, some water. Cement and water together are going to make, or Portland cement and water are going to make our cement paste, it's sometimes called, our glue. Then we're going to need some kind of coarse aggregate and some kind of fine aggregate. So you need some bigger things and some smaller things to try to fill up as much of the volume of our mix with structural material. Then you might add a tensile additive, and there's always going to be some air. So what you need to do is collect your materials and then decide based on a little bit of research or just playing around, however you want to do it, what your relative ratios of those materials are, and just fill those in here. So if you think, okay, I want based on looking at a chart or something I read, or just I'm just going to try it. I want to put 10% cement, 10% water, 45% aggregate, whatever. You need to add up to 100. And that's going to be done automatically by this spreadsheet. So let me step back a second and talk about how this spreadsheet works. Um, First, this is just Excel. You've seen it before. I just lay things out a little bit differently, and I use them in a more architectural way. So, for example, I've got my grid lines turned off. Um, I can, I can make these anything I want show up with, different colors or, grids. So I've just laid this out in a way that's a little bit more like a clearer uh, graphic little modeler. I always include terms. So if you see OZ, we know it's ounce. CC is cubic centimeters. Portland cement is PC, etc. In my spreadsheets, usually I color code the cells so that blue means that that's a cell that you can enter. It's a variable that's you can change. Uh, Cells that are yellow usually are an equation. I'll show you that in a second. Red cells are constants that we typically don't want to change because, for example, ounces to cubic centimeters is something it's a mathematical value that we look up. And then the total is going to be green. So, for example, this column of cells are totaled up to be this cell here. And the way Excel works, it's a visual coding language basically. So for example, if I wanted to sum up these cells into where the sum is this cell, you can see that if you click here on the cell, I come up to this formula bar, and there's a little formula here. Sum is, and I'm not expecting you to know how to do this. I'm just showing you this is you can look in the cell and see what's going on. It's the sum of these cells is what is depicted in this green cell. And so likewise over here, I've got the total volume in ounces times this percentage gives me the number of ounces of that material that I'm going to need. Uh, Etc. So let me now go through exactly how this whole thing is set up. I I decided based on looking at I just took the tubs that you were given and figured out that I think they're probably 16 ounce or they might be 14 ounce tubs. I decided just on my own that I wanted to use 10 ounces of the tub for my concrete mix because I wanted to have some room for that little eyelet. And anyway, it just was a round number. So I am saying that my total mix is 10 ounces, it's volume. Then I decided, well, if I get some Portland cement and I get some aggregate, like some gravel and some sand, and I mix them together, they're going to settle. Like so, the sand's going to fill the spaces between the gravel, or the rice is going to fill the spaces between the cereal. Um, and so it's actually going to be a smaller amount once they're mixed together. So I'm adding a little bit of volume to take uh, to adjust for that reality. So this is if you wanted to do more than 10, you can change this to 12, for example, or whatever you think, and that will adjust our numbers. I'll go back to 10. If you don't think that you want to have a settling adjustment, you can put this at 0. Um, and then ounces to cc's or is a looked up constant. I look at the bottom of the plastic scoops we were given, and they say that they're 60 cc, so that's where that number comes from. And then you'll see that if I first of all, I need to manually make these numbers added up to 100. So if I change my cement to 5%, I'm going to need to add 5% somewhere else. Always bring the green total here to 100 if you can. Just Control Z back. Um, then this value comes from multiplying the percentage of my cement, or whatever, whichever variable I'm looking at, by the total volume. Then I multiply that times the settling um, coefficient here. And then finally, I do a conversion from ounces to cc's and cc's per scoop to give me the number of scoops. Now, I'm not expecting you to follow that. I just wanted to show you how this works. All you need to do is open this spreadsheet up, which I'm going to put on Canvas. Decide if you accept that you want to have a 10 uh, ounce volume. Decide if you want to have a settling adjustment or not. Then choose your materials, right? Then create a mix design by deciding the percentage of each of those materials you're going to use in your mix. The air is really going to be a guess from observation. You're always going to have air, but if you think, well, this is kind of going to be frothy, it looks like there's going to be some space left in here or whatever, um, your observation tells you, then adjust that value accordingly. It's not going to be, it's not a real number, it's something that we're just guessing. All of this is just an experiment, and it's much better having these numbers than not having any numbers at all, right? So that's kind of the point here. We're trying to quantify something as closely as we can. Then, once you have all these materials, take the dry stuff, so the cement and the aggregates and the tensile additive, and mix them together in the tub. Shake it up. Try to make them homogeneously mixed so that it's all equally distributed. Then start slowly adding your water and mixing. This is, if your concrete is too wet, it'll be weak, and it also will take a long time to cure, and it might not even in the end work if you have it too wet. Um, you can base this on what you look up in terms of your water ratios that you find. If you look up concrete to water, or I'm sorry, cement to water ratios, that will probably be by weight, not by volume, which is what we're doing. So, not to confuse you, I'm just saying don't worry about it too much. Just as you start putting water in, if it's more than the 10% that you had here or the 5% that you had here, just take a note of that and change it in your calculation. Um, but all you're doing then is putting in those values here, and then automatically these numbers are going to be generated. All you need to know is the amount of scoops you need to put in of each material based on your mix design. So again, I did a bunch of talking to get to this point, but all you're doing is opening this up, saying, yes, I'm going to do 10-ounce volume concrete pour. I like the 10% settling adjustment, or I'm going to change it. I want these percentages of my materials that I've chosen. Once you have those, you'll see the number of scoops you need of each. Then you can make your mix. If you have more than one, what I would do is come down here and move or copy. So if I move or copy, I can select this sheet, hit create copy, and it will create a new uh, I'll just say 3. I can move these. So now I have an exact copy of this that I can make, and then I can name it something different. I can say this is mix 2 or whatever, right? Um, then come to class with your concrete and your spreadsheet, and we'll look at them. Uh, Anything else? I would leave the tops off your tubs as the concrete's curing. It'll take at least a day, I would imagine. It may take longer for that to cure. So do this soon. It shouldn't take you very long. You should be able to find stuff just laying around that you want to use as your fine and coarse aggregates. The cement we gave you, water is available, and tensile additives are optional. All right, that's all I have. As always, let me know if you have any questions.